Welcome, my name is Ronald Rodriguez, Senior Solutions Architect, and I am part of the Global Security and Compliance Acceleration Program, previously known as the Authorization to Operate or ATO on AWS. These security talks are focused on introducing you to the technical side of AWS regarding compliance, certification, and regulations such as FedRAMP, CIS, GDPR, HIPAA, SOC 2, and others. I will provide links during and at the end of this presentation so you can learn more about our partners, my team, and our program. For this security talk, I'll be covering compute with a focus on first, Elastic Compute Cloud or EC2, and I will provide you with a quick knowledge pointer on operating systems. Second, Elastic Load Balancers or ELB, and finally, AWS Outposts. Let's start with Elastic Compute Cloud or EC2. We can't ignore the virtualization infrastructure that powers it, the AWS Nitro System. The AWS Nitro System brings enhanced security that continuously monitors, protects, and verifies the instance hardware and firmware. Nitro System security model is locked down and prohibits administrative access, and by this, eliminating the possibility of human error and tampering. It has the following key features or components. Number 1, the Nitro cards. 2, the Nitro security chip. 3, the Nitro hypervisor. 4, AWS Nitro enclaves. And lastly, Nitro TPM. All providing strong isolation between the host hardware, firmware, and software. Now, why this is important for you and in the context of security and compliance? When talking about FedRAMP and the requirement of encryption in transit, data protection, and other related items or controls, data flowing or in transit across the AWS global network connecting our data centers and regions is encrypted before it's transmitted between facilities. TLS connections are used in addition for service-to-service or customer-to-service communication. Further, if you have a requirement on FIPS 140-2, you should leverage AWS KMS or AWS Cloud HSMs using FIPS 140-2 Level 3 validated hardware secure modules. Another example, when talking about personally identifiable information or PII, and customers or partners that have a requirement such as HIPAA compliance, you can leverage the AWS Nitro enclaves. These enclaves help customers create isolated compute environments to further protect and process sensitive data such as PII. By design, the Nitro system has no operator access. There is no mechanism for any system or person to log into the EC2 Nitro hosts, access the memory of EC2 instances, or access any customer data stored on local encrypted instance storage or remote encrypted EBS volumes. If any AWS operator, including those with the highest privileges, need to do maintenance work on an EC2 server, they can only use a limited set of authenticated, authorized, logged, and audited administrative APIs. None of these APIs provide an operator the ability to access customer data on the EC2 server, because these are designed and tested technical restrictions built into the Nitro system itself. So no AWS operator can bypass these controls and protections. It also follows a passive communication design principle. What that means is that during production operation, components of the system never initiate outbound communication, including to any control plane management or cloud service. Finally, all Nitro system related configurations and code changes are subject to multi-party review and approval, and staged rollouts are performed in both testing and production environments. A security review, in addition, is conducted by both the independent AWS security team as well as the Amazon EC2 engineering team for significant changes or features. Elastic Compute Cloud, or EC2, leverages the AWS Nitro System that provides enhanced security for that instance hardware and firmware. As a reminder, applications that are built on top of AWS services are not implicitly compliant with security controls that AWS services are compliant with. Customers must certify and validate their applications separately by coordinating with external auditors. When using EC2, customers can pick and decide at the moment of launch what operating system they want to use to run their instance. You are responsible of the configuration of the operating systems running in that instance. You have a set of Amazon machine images that are pre-configured with an ever-growing list of operating systems, including Microsoft Windows, Linux distributions such as Amazon Linux 2, Ubuntu, Red Hat Enterprise Linux, CentOS, and others. When looking at regulations such as FedRAMP and to comply with FIPS 140-2, your operating system must be configured to run in a FIPS-approved mode of operation, which leverages a cryptographic module that uses only FIPS-approved algorithms. When this is enabled in the operating system, it forces the OS to run in FIPS-validated encryption. Here is a link in how to perform this in an Amazon Linux 2 instance. In this link, you will find details in how to enable FIPS 140-2 mode in your Amazon Linux 2 instance and how to verify this as well. Also, consider that there are other configurations required at the OS layer that are needed for any of the regulations previously mentioned. You can always leverage the marketplace where AMIs have certain pre-configurations in place that help you gain time in deploying your secure applications or workloads. Further, we also have AMIs in the marketplace that can help you or already have the configuration required towards a regulation or certification or compliance framework. For example, here is an AMI from CIS that already leverage some levels of configurations that you can use to your benefit. As part of compute, we also have Elastic Load Balancing, or ELB. ELB automatically distributes incoming traffic to applications across multiple targets. There are three types of load balancers: application load balancer, gateway load balancer, and network load balancer. For all three, customers are responsible for selecting network configuration settings for ELB, which can include configuring ports, protocols, IP addresses, and service access points to facilitate secure traffic flow. Customers should configure network settings in accordance with their organizational and regulatory requirements. You can also choose from predefined security policies for a load balancer to specify the cipher suites and protocol versions that it will be used or enforced in that traffic. Make sure you are using appropriate cipher suites per your regulatory requirements. If FIPS 140-2 compliance is required for control plane connections, customers should utilize the ELB FIPS API endpoint when supporting sensitive workloads to ensure that FIPS 140-2 approved algorithms are being executed by FIPS 140-2 validated cryptographic modules. FIPS endpoints for the ELB API operations can be found here. Customers that have FIPS 140-2 usage requirements and are using the Application Load Balancer, or ALB, should contact AWS for the latest offering details. For Network Load Balancer, customers can configure a listener with a protocol and a port for connections from clients to the load balancers, and a target group for the default listener rule. When using NLB, the customer is responsible of configuring and choosing the target endpoint with only FIPS-validated cryptographic algorithms, in addition to configure their SSL certificate on the FIPS-enabled target. Our last item for this discussion, AWS Outposts. Customers, when using AWS Outposts, are required to follow a data residency control, which means that all customer content be processed and stored in an IT system that remains within a specific physical location or physical boundary. AWS Outposts is a great service to serve this type of use case. First, as we discussed in our previous Security Talk session, you need to consider the shared responsibility model and all the time you use an AWS service. You are responsible to have an understanding in how this applies to each of the services you're using. So let's take a look. When using AWS Outposts, the shared responsibility changes. You need to consider physical security and access to the racks themselves, redundancy of the electrical inputs for the rack or the server. In addition, all the services that are supported to run on AWS Outposts, such as EC2, those also need to be configured, and you're responsible for the proper configuration of encryption at rest, in transit, and enforcement of data residency, and others are followed or applied to those services supported by AWS Outposts. It is the sole responsibility of you and your organization to determine which regulatory requirements are applicable and to ensure that you comply with them. Although this solution addresses challenges such as data residency, where you have full control of where workloads run and your data resides, you still need to solve for other controls or requirements needed. If you're looking for assistance in any of these discussions, our team focuses on working with AWS partners with experience and delivery of secure and compliant workloads. These AWS partners can help customers secure various workloads to meet regulation and compliance guidelines, reducing time and cost in achieving ATO or authorization to operate. We recognize that architecting workloads to meet security, regulations, and compliance requirements can be challenging. My team has security strategists and solutions architects with the knowledge of assessments, certifications, and authorization process, and we can help you navigate this journey. As part of our program, we provide informal advisory service at no cost for compliance frameworks across healthcare, privacy, national security, financial sectors, and more. However, if you're looking for additional ongoing and even hands-on support, our partners can help you navigate, automate, and accelerate building compliant workloads on AWS and reduce time and cost when doing so. Our team will help you connect with the right partner for your security and compliance needs. Please reach out to us through any of the displayed links to get support or assistance regarding your secure and compliant workloads. My name is Ronald Rodriguez. Hope this has been informative for you. Until next time, thank you.